welcome to the next edition of the BriefingsDirect Voice of Analytics Innovation podcast series. I'm Dana Gardner, Principal Analyst at Inter Arbor Solutions, your host and moderator for this ongoing discussion on the latest insights into data science advances and strategy. Businesses these days are quick to declare their intention to become data-driven, yet the deployment of analytics and the use of data science remains spotty, isolated, and often uncoordinated. To fully reach their digital business transformation potential, businesses large and small need to make data science more of a repeatable assembly line, an industrialization, if you will, of end-to-end data exploitation. Stay with us now as we explore the latest methods, tools, and thinking around making data science an integral core function that both responds to business needs and scales to improve every aspect of productivity. To learn more about the ways that data and analytics behave more like a factory and less like an ivory tower, please join me now in welcoming our guest. We're here with Doug Cackett, EMEA Field Chief Technology Officer at Hewlett-Packard Enterprise. Welcome, Doug.
Thanks very much, Dana.
Doug, why is there a lingering gap, and even really a gaping gap, between the amount of data available and the analytics that should be taking advantage of it?
Oh, that's such a big question to start with, Dana, to be honest. We probably need to accept that we're not doing things sort of right the way it is at the moment. Actually, Forrester suggested that something like 40 zettabytes of data are going to be under management by the end of this year, which is quite enormous, of course. And significantly more of that data is being generated at the edge as well, so through applications, IoT, and all sorts of other things. And really, this is where your customer meets your business, and this is where you're going to have to start making decisions as well. So the gap is two things, really. It's the gap between the amount of data that's being generated and the amount you can actually comprehend and create value from. But in order to really leverage that data from a business point of view, you need to make decisions at the edge. So you need to operationalize those decisions and move that to the edge where your business meets your customer. And that's really the challenge. And that's the challenge I think we're all looking for machine learning and more the operationalization of those machine learning models into applications to make the difference.
And why does HPE think that moving more towards a factory model, industrializing data science, is part of the solution to compressing and removing this gap?
I mean, I think it's a maths problem, really. If you think about it, if you would agree that there is this exponential growth in data, and at the same time then within your business, if you're trying to optimize every step in every business process you have, and again, we talked about it already, but operationalizing sort of that insight, if you like. So trying to make your applications as smart as they can possibly be by embedding machine learning into those applications. So correspondingly, there's this sort of exponential growth in the demand for analytics in your business. And yet, the number of data scientists that you have in your organization, growing them exponentially isn't really an option, is it? And of course, budgets are also pretty much flat or declining. So it's a maths problem because we need to somehow square away that equation. We somehow have to generate exponentially more models from more data, get them to the edge, but do that with fewer data scientists and lower level of budgets. Industrialization, we think, is the only way of doing that. Through industrialization, we can remove waste from the system, we can improve the quality and control of those models. And I think all of those things are going to be really key going forward.
So when we're thinking about the industrialization, we shouldn't perhaps be thinking about an assembly line of 50 years ago where there were a lot of warm bodies lined up. I'm sort of thinking about the Lucille Ball assembly line where all the candy was coming down and she couldn't keep up with it. But more perhaps like the modern assembly lines where it's a series of robots with a few very capable people involved. Is that a fair analogy?
Yeah, I'm just wondering about the Lucille Ball reference, actually, because I have no idea, of course.
I'm dating myself, really.
But notwithstanding that, yeah, I think that's right. I mean, what we're definitely not looking to do, I mean, if you think about it, industrialization was really about, I guess it was coined originally about sort of the move from an agrarian sort of way of living, if you like, to manufacturing, where we replaced sort of manual labor with mechanical sort of mass production and that kind of thing. We're kind of not talking about that, because we're not talking about replacing the data scientist. The data scientist is really key to this. But what we want to do, in the same way as if you look at a modern car plant, we want to make sure that the data scientist is we're maximizing the value from the effort of the data scientists, if you like. So we don't want them going around hunting for the right tools to use. We don't want them waiting for the production line to catch up with them or for the supply chain to catch up with them. In our case, of course, that's mostly data. Or waiting for infrastructure or waiting for permissions to do something. I mean, all of those things are a complete waste of their time. Often, if you look at the amount of productive time a data scientist spends actually creating value, doing things, it can be pretty small compared to their non-productive time. And that's a concern. Part of the non-productive time, of course, as well in the past might have been with those data scientists having discovered or determined a model and optimized it, going on to actually do the steps to operationalize it. So maybe doing the data engineering things and the ops engineering things that they needed to do to actually operationalize the model. And that's much more efficiently done with another team of people, who have the skills to do that. So we're talking about specialization here, really. But there are some other learnings as well. I mean, I've recently written a blog about it, actually, Dana, it just so happens. And I kind of lent on the Toyota production system and started to ask questions around what we could learn about what they've learned, if you like, over the last 70 years or so. So it was all about kind of not just automation, but also how they went about doing R&D, how they approached tooling, how they did continuous improvement as well. I mean, we've got a lot to learn around that area, as I'm sure you're aware, because there are an awful lot of organizations that I certainly deal with that haven't had a lot of experience around their operationalization problems and therefore haven't built that part of their assembly line yet. Supply chain and also mistake-proofing things, what Toyota call poka-yoke, are also really important. So they're just some things, but this is an area that's continuously developing. It's a really interesting area to be involved with.
It's interesting for me on a historical context because listening to you reminds me of what manufacturing in the bricks and mortar sense went through back in the early 80s when they had to have process reengineering and they did Kaizen and they did Deming and quality. And so there was a revolution, if you will, in physical manufacturing. And now it sounds like we're at that cusp of a same sort of watershed moment in how data and analytics are processed.
Yeah, that's exactly right. I mean, I hate to say it, but another sort of to extend that analogy a little further, I just recently saw, it was like a documentary actually on TV, and they were talking about Morgan Cars in the UK. And they're a hand-built kind of car company, quite expensive, very hand-built, very specialized. And I ended up by almost throwing things at the TV because they were talking about the skills of this one individual, and they only had one guy who could actually bend the metal to create the bonnet, the hood of the car, in the way that it needed to be done. And it took 2 or 3 years to train this guy. And I'm thinking, well, if you just automated the process and a robot built it, you wouldn't need to have that variability. I mean, it's just so annoying. In the same way, data science here, we're talking about laying bricks, not not Michelangelo kind of hammering out the figure of David. But what I'm really trying to say is a lot of the data science in our customers' organizations are fairly mundane. To get that through the door and get that done and dusted and give them time to do the other bits, the more of a finesse, if you like, and take more skills, that's really what we're trying to achieve, I think. So both of those things are necessary, but they can all be done on the same production line.
All right, Doug, if we are going to reinvent and increase the productivity generally of data science, it sounds like technology is going to be a big part of the solution, but as often is the case, technology can often be a big part of the problem. What is it about the way that organizations are deploying technology now that needs to shift, and how is HPE helping them readjust to a different approach to the technology that supports a better data science approach?
Well, we can probably all agree that most of the tools around machine learning sort of technologies, if you like, have been around model building and model optimization, hyperparameter optimization, and that kind of thing. The tooling around ML ops is actually all relatively young. So the two types of company we see are either companies that haven't yet got to the stage where they're trying to operationalize more and more models. So in other words, they don't really understand what the problem is yet. And I mean, Forrester Research recently has suggested that I think it was only 14% of organizations that they surveyed actually suggested that they had a robust and repeatable operationalization process. So it's clearly 94% or whatever of organizations, or 96% of organizations just haven't or 86 rather, just really haven't refined what they're doing yet. And that's often because it's quite difficult. Many of these organizations have linked their data science to their big data estates, to their data lake, for instance. And they're using it both for the workloads, if you like, to develop those models. And therein lies a problem, often because they get stuck with simple things like either everyone has to have a uniform environment. So all of your data scientists are now sharing data and sharing the compute environment as well. And data scientists can often be very destructive in what they're doing, maybe overwriting data, for instance. So to avoid that, the first thing that has to happen is you end up by replicating the data. And if you're going to replicate terabytes of data, that can take a long period of time. That also means you need new resources, maybe more compute power, and that means approvals, and it might mean new hardware. So often the biggest challenge actually is just in provisioning the environment for a data scientist to work on and the data that they want and the tools they want. So that can often lead to huge delays in the process. And as we've talked about, this is often a time-based problem. You want to get through more tasks. And so every delayed minute or hour or day that you have is a real challenge. The other thing, and this is really key actually, I think as well, is that data science is very peaky. You'll find that a data scientist may need no resources at all Monday and Tuesday, and they then may burn every GPU you have in the building Wednesday, Thursday, and Friday. So managing that as a business is also really important. If you're going to get the most out of the budget that you have and the infrastructure you have, you need to think differently about all of these things.
And Doug, how is HPE Ezmeral being designed to help give the data scientists more of what they need, how they need it, and then also help close the gap between the ad hoc approach and that desired assembly line approach?
The thing to do is to look at it as an assembly line. In fact, look at it as two assembly lines at the very minimum. That's the way we like to look at it, at least. The first being the data scientist doing the discovery, and the second maybe in the MLOps process. So a range of people, if you like, operationalizing those models. So imagine, if you will, you're a data scientist, Dana, and I've just given you a task. So whatever that may happen to be. So let's say there's a high defection rate, churn rate from our business, and you want to investigate why, right? So you're going to look around and you want to find out a little bit more about the problem, because you might have to break that problem down to a number of steps. And then in order to do something with the data, you're going to want an environment to work in. So maybe in the first step, you simply want to go and define the project, how long you've got this time box project for, and give it a cost center. You may go on then to define the environment. Maybe you need CPUs or GPUs. Maybe you need them highly available or maybe not, right? Or the different sizes of environment. So you'd select the appropriate one. You then might, from the tools catalog, an open tools catalog this is as well. So we're not forcing you to use a specific tool. We've got a range of tools available. You select the tools you want to use. So maybe you're going to use Python. I know you're hardcore, right? So you're going to code. So you're going to use Jupyter and Python and a whole bunch of pandas and things. Okay, and the next step, you then want to trawl around and find the data. So maybe through the data catalog, you then want to locate the data that you want to use, and then you want to push a button and get provisioned for that lot. And you don't want to have to wait months for that. That should be provisioned straight away. You can do your work then, and then you can save all your work away into a version repository, and you can save the data that you use so it's reproducible. And we can also then check for things like model drift and data drift and those sorts of things. And you can save the code and model parameters and those sorts of things away. And then you can put that on the backlog for the MLOps team. MLOps team then pick it up, and they're going to go through a similar process, Dana. They want to create their own production line now, right? And so they're going to have a different set of tools, this time CI/CD plus a whole bunch of data stuff they want to do maybe to operationalize your model. They're going to define the way that that model is going to be deployed. Let's say we're going to use Kubeflow for that. So they might decide on, say, an A/B testing process. So they're going to configure that, do the rest of the work, and press the button again, right? So this is a process, and that fundamentally, that workflow and the automatic provisioning of the environment to eliminate the waste, that wasted time waiting for stuff to be available, is fundamentally what we're doing in our MLOps product. But in a wider sense, we've also got consulting teams that are also helping customers get up to speed and define these processes and build the skills around the tools. And we can also do this through our GreenLake proposition as well. So if you want to do this as a service, again, those are the kind of things that we're helping customers with.
We had an analogy to old-fashioned factories, but it sounds like, Doug, that you're describing with the changes needed in data science what we also had needed for application development. And so the advent of DevOps several years ago, is there commonality between what we're doing with the flow and nature of the process for data and analytics with what we were doing back not too long ago with application development and making it more of a cattle approach than a pet approach?
Yeah, I completely agree. That's exactly what this is about, really. And the MLOps process is exactly that. So it's analogous to the sort of CI/CD DevOps part of that business, right? But a lot of that tool chain is being taken care of by things like Kubeflow and MLflow, some of these newer technologies, open source technologies. I should say, actually, that again, this is all very new, and all of the ancillary tooling that kind of wraps around that CI/CD CI/CD set of tools is also pretty new. So what we're also attempting to do is allow you as a business to actually bring these new tools sort of onboarded, so you can evaluate them, see how they might impact what you're doing as your process is settling down, to put those in a wrapper and then make them available. So we've got much more of a dynamic feel to this because we're progressing. I mean, the way that we're doing MLOps and data science generally is progressing extremely quickly at the moment. So what you don't want to do is lock yourself into a corner where you're trapped into a particular workflow, if you like. You want to be able to have some agility around this. But yeah, completely agree. It's very analogous to that movement. And in fact, part of the process, in fact, we started off by talking about it, Dana, as well as operationalizing the machine learning model, the other thing you're going to have to do is pay attention to the changes that need to happen to your operational applications, because you're going to have to change those so that they can call the machine learning model at the appropriate place, get the result back, and then render that result in whatever way is appropriate. So the changes to the operational app are also important.
And to have a meaningful impact on this, because it is sort of the larger picture of how these tools and platforms and methods are brought together, you really couldn't do this if you were just a tool provider. You couldn't really just do this if you were a cloud services provider. You couldn't just do this if you were a professional services provider. It seems to me that HPE is actually in a very advantageous place to allow the best of breed approach where it's most impactful to continue, but to start to put some glue around this operationalization, if you will, the industrialization. Explain why HPE is in an advantageous place to have a meaningful impact on this difficult problem.
Hopefully we're in an advantageous place. And as you say, it's not just a tool, is it? I think if you think about the breadth of decisions that you make in your organization and how many of those could be optimized using some kind of machine learning model, you'd understand that it's very unlikely that it's going to be a tool. It's going to be a range of tools, and that range of tools are going to be changing probably almost constantly over the next 10 and 20 years. So this is much more to do with platform. Because this area is relatively new, like any other technology when it's new, it almost inevitably, to start with, tends to be a very technical implementation. So, using the tools is very difficult. And tools that are very mature tend to have a very mature UI, and a well-defined process, and have become very simple to use. But at the moment, we're way up the other end. I think this is about platforms, and what we're providing in HPE is the platform through which you can plug these tools in, and if you like, integrate them together. So you can, you've got freedom to use whatever tools you want, but at the same time, you're inheriting the back-end system. So that's AD and LDAP integration, that's linkage back to the data, your most precious asset in your business, whether that be in a data lake or a data warehouse, data marts, or even a streaming application of some description, that kind of thing. So I think this is at the melting point of the business at the moment. And with HPE, have had a lot of experience of helping our customers deliver value through information technology investments over many years. And that's certainly what we're trying to do right now.
Yeah, and it certainly seems that HPE Esmeralda is the culmination of that. But I know this varies from company to company and vertical to vertical. But is there any aspect of Esmeralda and moving towards industrialization of data science that you should start with? Is there a certain order by which this becomes more fruitful than others? So where do you start?
Where do you start? It's a very good question. This is such a hard question to answer as well, Dana, I think. And it's so dependent on where you are as a business and what you're trying to achieve. Typically, to be honest with you, we find that the engagement is normally when there is some element of change in our customers. So that's often, for instance, where there's a new digital transformation initiative going on. And you'll find that the digital transformation is being held back by, for instance, their inability to do the data science that's required. Actually, that brings me to, there was another Forrester report, which I thought, I'm sure you'll find interesting. This Forrester report suggested that 98% of leaders, if you like, in business felt that machine learning was the key to their competitive advantage. So it's hardly surprising that machine learning is so closely related to digital transformation, right? Because that's about how the edge at which organizations are competing, after all. So we often find that that's the starting point. So why can't we develop these models and get them into production in time to meet our digital transformation initiative? And then it becomes, well, what bits do we have to change? How do we transform our ML ops capability to be able to do this and do this at scale? So often it's led by an individual in an organization. There's a momentum in an organization to make these changes. But the changes can be really small to start, of course. You might start off with just a single machine learning problem related to the digital transformation and then build on from there. So starting to build capability and capacity in an organization. The other thing I would say as well, you'll know, Dana, that we acquired MapR some time ago, which has now become our data fabric, and it's the thing that actually underpins a lot of the work that we're doing. And so we'll often also start with the data, to be honest with you, because a lot of the challenges in many of our organizations is to do with the data. And sort of as businesses become much more real time and want to connect more closely to the edge, really that's where the strengths of sort of MapR and the data fabric really come to play. So again, another starting point might be the data. So a new application at the edge has new requirements very stringent requirements for data, and we'll find we start there with building these data systems, if you like, using our data fabric. And that leads on to a requirement to do the analytics and brings us obviously nicely to our MLOps, and the data science proposition that we have.
Yeah, Doug, I'd like to revisit briefly your point that sometimes it's a crisis that prompts organizations to the change that they need. Without going too far down this path, is the COVID-19 pandemic a point that is prompting people to bite the bullet and go in and say, we have to operationalize our data because we need to be fleet and agile, and we're doing things in ways that we just couldn't anticipate before?
Yeah, I'm sure it has. I mean, we haven't seen it yet, in fairness, Dana, so not certainly across Europe, Middle East, and Africa. We know it's happening. We've seen all the research as well. I think what it has done, as McKinsey have pointed out, it's accelerated a digital transformation journey, hasn't it? And inevitably, that's going to mean that more data science going forward, because as we talked about already with that Forrester research, right, 98% think that it's about competitive advantage, and it is, frankly. The research goes back a long way to people like Tom Davenport, of course, and his famous Harvard Business Review article. We know that customers that do more with analytics, are better at analytics, outperform their peers by any measure, and machine learning is the next incarnation of that, of course.
All right. We've talked at this very intellectually, if you will, at sort of an abstract level, but it helps a lot when people can see a concrete example. Do you have any cases of named or unnamed organizations that have gone more towards the assembly line, industrialization approach to data science, and what has it done for them?
Yeah, of course we do. I'm afraid names are going to have to be left out, probably, although we can, one of them I can probably talk about. But a good example would be a lot of the examples that probably have gone further and faster in this area are probably financial services, to be honest with you. Again, because they have more of a problem, more of a requirement in terms of regulatory requirements as well. So one of them in particular, for instance, we've been involved with them for quite some time. So again, you'll know that we acquired Blue Data some time back, and Blue Data, and this is the underlying technology which we've transformed into our MLOps and container platform propositions. And with Blue Data, they've had a long history of containerizing sort of very difficult, problematic workloads. In this particular case, it was actually Hadoop, funny enough, a Cloudera. So this particular financial services organization had a real challenge. They wanted to bring on new data scientists. But the problem is every time they wanted to bring a new data scientist on, they actually had to go and acquire a bunch of new hardware because their process required them to actually replicate the data and completely isolate that new data scientist from the other ones. This was their process. That's what they had to do. So as a result, it almost took them 6 months to do anything, frankly. And yet when you looked at their ramp rate for new data scientists, there's no way that was really sustainable. I mean, it was a well-defined process, but it still involved a 6-month wait each time, right? So we instead containerized their Cloudera implementation, separated compute and storage in that regard as well. So that meant that we could now start to create environments really on the fly within minutes, effectively on the request, for a new challenge, really in very much the way that I described earlier, hopefully. But it also meant that we could take read-only snapshots of data. So the sort of read-only snapshot is literally just a set of pointers, so it's instantaneous. So they could scale out their data science without scaling up their costs and scaling up the number of people they required. Interestingly, recently, they've moved that on further as well. So they're now doing all of that in a hybrid cloud environment, and they only had to change 2 lines of code to allow them to push workloads into AWS, for instance, which is pretty magical. And that's where they're doing their data science. Another good example, actually, I can name is GM Finance. So GM Finance, just a fantastic example of how, having started in one area of the business, really, which was really all about risk and compliance, but they've been able to think about that. So things like credit risk, for instance, but doing credit risk and risk in terms of insurance also meant that, for instance, for some drivers, they've got black boxes so in the car, so they can actually start to look at pricing based on risk because of the way you're driving. It's about you, Dana, but I drive like a complete idiot. So, I couldn't possibly afford that rate. But you, I'm sure, drive very safely. But in this case, what they're also able to do, because they've now got the time to do the data science because of what we've been doing with them, it means that they can, when your car gets to the end of your lease period, they know how the car's being driven. So they're able to look at the value of the car at the end of that lease period and create more value from it, if you see what I mean. So this is a detailed thing we're talking about. This is about giving our customers the time back they need to do more data science. And because the data science becomes better, you're more able to do more data science. You can create momentum in your organization. That means you can do more data science. It's really a very compelling proposition.
All right, Doug, we're coming up towards the end of our time. And usually this is the point where I ask people about the future, what's coming next. But I'd like to ask it in sort of the same way as I asked you about examples. If I were to come to you in 3 years, Doug, and say, give me the example of a company that has done this right and has really reshaped itself, describe what you think an analytically driven company will be. What is the end state that we want to get to?
Can I answer it in 2 ways, right? One is I remember talking to an ex-colleague, actually, who worked for Facebook, and I was so taken with what they were doing there. Basically, he said, originally what happened in Facebook is they would create a new product in Facebook, right? You'd have an engineer and a product owner. They'd sit together. They'd create a new product. And sometime later, they would ask a data scientist to get involved to look at the data and tell them what the results were. Completely change that around. What they do now is they find the data scientist and bring him on board when they're creating the product in the first place, so that they're instrumenting up what they're doing in the way that best serves the data scientist, which is really interesting, right? So it's built in. And if you ask me what's going to happen in 3 years' time, as we move to this democratization of machine learning, that's exactly what's going to happen. I think we'll end up by genuinely being kind of information driven as an organization. And that we'll have to build the data science into the products and the applications from the start, not tack them on to the end. Does that make sense? Hopefully it does.
Yeah, no, it really does. And when you do that, it seems to me the payoffs are expansive and perhaps accelerating.
That's about the competitive advantage we started off by talking about, I think, right? But the technology has to underpin that. If you can't deliver the technology, machine learning won't sort of deliver on its promise, and then you won't get the competitive advantage, and your business or your digital transformation in your business will also fail. So this is really about getting the right technology with the right people in place to deliver these results, of course.
Well, great. I'm afraid we'll have to leave it there. You've been with us as we explore how businesses can make data science more of a repeatable assembly line, an industrialization, if you will, of end-to-end data exploitation. And we've learned how HPE is ushering in the latest methods, tools, and thinking around making data science an integral core function that both responds to business needs and scales to improve nearly every aspect of productivity. So please join me in thanking our guests. We've been here with Doug Cackett, EMEA Field Chief Technology Officer at HPE. Thank you so much, Doug. It was a great conversation.
Yeah, thanks, everyone. Thanks, Dana.
And a big thank you as well to our audience for joining us for this sponsored BriefingsDirect Voice of Analytics Innovation discussion. I'm Dana Gardner, Principal Analyst at Inter Arbor Solutions, your host for this ongoing series of Hewlett-Packard Enterprise-supported discussions. Thanks again for listening. Please pass this along to your community and do come back next time.